Hello, scholars. Time for us to continue our math notes. We've got some Module 4 notes to work on now. We are going to be discussing something that I've talked about in class. Hopefully this is not going to be the first time you've heard it, but we're going to say it, at least to start, in a very fancy way. This is going to be Module 4, Lesson 2, Interpreting fractions as division. Interpreting fractions as division. Okay. Module 4, Lesson 2 means our Roman numeral is going to be 1, 2 I's. No, not I's, or even letter I's, but it looks that way. Interpreting fractions as division. One thing I always like to show every year, and I've probably already done it in class, if you write a fraction, we'll pick something easy like 1/2. Now, if I write 1/2, there we go. But then I scribble out the 1 and scribble out the 2. It's a division symbol. The division symbol is a fraction. The division symbol that you've been using since you learned how to divide is basically just a little tiny fraction. So this really isn't going to be hopefully too big of a jump. There is a big connection here. We're just going to practice. Now, before we do that, we're going to do a little bit of vocabulary. This is going to seem unrelated at first. Bear with me. This vocabulary has to do with the different number systems that we use in math, the different number systems that we use as mathematicians. Okay. We're going to start nice and basic with what we call the natural or counting numbers. Actually, I should have a closed parenthesis right there, closed parens. The natural counting numbers. Okay, this is what you learned when you were 3 or 4. 1, 2, 3, 4, and so on forever and ever and ever. If you are counting something in the real world, you start with one of those items, then there's 2 of them, 3 of them, and so on. Now the next number system, and this is going to seem like kind of a silly number system, but it is an important distinction in math. We're talking about whole numbers. Now the whole numbers, many of you are probably looking at this and saying, well, aren't those whole numbers? And they are. Every single one of these is a whole number. On and on and on and on and on forever. There is only one difference. 0. It may seem silly to kind of think about this, but 0? We didn't always have an idea for 0. We didn't always have a number symbol that represented nothing. Adding this on, and really there's no real way to show 0. You can't show nothing. It's just nothing. Having this symbol, bumps us up into whole numbers. Okay. Our next system, integers. Okay, integers. Includes everything in the systems above. Includes all of the counting numbers. 1, 2, 3, 4, blah, blah, blah. It also includes 0. So it includes all the whole numbers. And it also includes what many of you probably first thought of when you saw the word integers. It includes the negative numbers. And for some of you, writing them backwards like that was probably uncomfortable, but we're counting back from 0. 1, 2, 3, 4 this way, -1, -2, -3 back this way. And really, that goes on and on forever as well. Okay. All right, so integers include all of the whole numbers, which included all of the natural counting numbers. What's left? That's what we have been talking about with fractions, what we've been talking about with decimals. These are called rational numbers. And we're not going to be listing numbers out this time. I'm actually going to give you a definition. Rational numbers are numbers which can be expressed. And remember that in math, when we say expressed, it's just a fancy way of saying written. We're going to share that information. Numbers can be expressed or written as a ratio, a fraction. You will learn more about ratios as you move into middle school. 6th and 7th graders talk about them quite a lot. For us, I'm mostly mentioning the term so you've heard it once, and you see why rational, rational numbers, where that word's coming from. Numbers which can be expressed, written as a ratio, a fraction, of 2 integers. Now, this is going to include all of the integers, all of the whole numbers, all the natural numbers, everything else. It includes -2 because I can write that as -2/1. It also includes -8/7. That looks weird. It includes -1. It includes -75/100. It includes -1/2. It includes 0. It includes all the positive versions of those numbers. 1/2. 75/100, 1, 8/7, 2, etc., etc., etc. And again, the etc., etc., etc. also goes out that way. So rational numbers, basically everything else, includes those counting numbers like 1 and 2, includes whole numbers. Remember, 0 was our big addition there. It includes all the integers, positive and negative numbers, but we're also seeing fractions. We're also seeing decimals. Now, we're going to talk later about how decimals can be written as fractions and vice versa. We've done a little bit of that. But for now, we're going to move past this and get to the actual fractions as division bit. Because really, remember, that's what we started with. That's what this lesson is mostly about. Recognizing that fractions, well, fractions are division. Fractions are division. You've got 2 parts of a fraction, just like you have 2 parts initially of a division problem. For a fraction, you have the numerator on top, right? And you have the denominator on the bottom. Numerator on the top, denominator on the bottom. Numerator, denominator. Okay. Well, the numerator of a fraction is basically the dividend in a division problem. The denominator is the divisor. Now, if you don't remember exactly what those are, it's been a little while since we've talked about it. I'll start by drawing my little division hut. The dividend goes on the inside, and the divisor goes on the outside. Okay? The dividend is what we're starting with. The divisor is how many pieces we're breaking it up into. Or we're breaking it into groups of a certain size, and the divisor tells us what that size is. For example, If I give you 2/3, that's essentially the same as saying, well, 2 over 3. And I know in the video, probably a little hard to see that fraction bar, so I'll darken it in. That's the same as saying 2 divided by 3. Numerator divided by denominator. Top divided by bottom. Dividend, divisor. So that is also the same as writing it as a division problem using a division hut. I'll go ahead and make it a little bigger than I normally would just to make sure it's clear. Dividend goes on the inside. This part's tricky for a lot of students, so please be careful. The top number, the first number, goes inside. This is really going to throw some of you because that's usually a smaller number, and we've talked before, oh, we're not supposed to do that. 5th grade kind of changes it up a little bit. Okay. All right. 2 divided by 3. Let me show you this a different way. Go ahead and draw. Here's 1. Two holes. Okay, 2 holes. Divided by 3. We're dividing up into 3 parts. Okay. Now, if I've only got 2 boxes, how are we going to do that? We have to break them up. I'll split this into 3. The divisor tells me that. I'll split this into 3. Okay. So really my 2 is equal to 1, 2, 3, 4, 5, 6 thirds. 6 divided by 3 would be 2. There's another example right there. But my 2 whole rectangles have now become 6 thirds. That I can break into 2 groups. Excuse me, 3 groups. Sorry, folks, got to break it into 3 groups. There's a group. There's a group. I know it looks really weird because it's stretched out, but I'm going to color in a minute and show you. There's another group. Now, you may not have colored pencils handy. If you would like to do this in color, you can always pause your video and go grab some colors. Otherwise, it doesn't really matter. You can just shade it in with pencil too, is fine. But I want to show you. I am going to make 3 groups. Here's that first group, 2 bars. And if you're wondering how I'm getting this, I'm just looking at that 6 thirds and saying, well, 6, okay, divided by 3, that's going to be 2 pieces, right? 6 divided by 3 is 2, okay. So there's one group. The next group's a little trickier because it splits across both of them, but I'm going to combine this and this. That's a group. And then the last one, this and this. Okay. If you look at each of these thin slivers as a third, that's 2 thirds. 2 thirds. There's 2 thirds. There's 2 thirds. If I have 2 candy bars and I want to share with 3 people, each person is going to get 2 thirds of the candy bar. Fractions and division are very closely related. Now, some of you may be looking at this going, what? This is something that can take a little time to wrap your head around. Do not get discouraged. The big thing I want you to remember for this lesson, your numerator is the dividend, denominator is the divisor. Top divided by bottom. Top divided by bottom. If you can hang on to that, You'll be able to do these first few examples, and we'll do some more together in class. We'll talk about it. We're going to continue playing with this and seeing why this connection works. Okay. I do want to start wrapping up the video since we're at the 15-minute mark, but we'll do just one or two more quick ones. 5/6. Like I said before, top divided by bottom. Top divided by bottom. Now there's no real reason for us to divide that out, because I'm telling you, if you divide 5 divided by 6, you're going to get 5/6. You're going to get the exact same thing we started with. So all I'm really checking right now is, do you understand that 5/6 is the same as 5 divided by 6? Can you go the other way? 9 divided by 5 equals, okay, give yourself a second, go ahead and write that fraction. Hopefully most of you recognized top is divided by bottom. Now this one is a little different because this is an improper fraction. This one we can change to a mixed number, so I'll go ahead and do that. If I need 5 pieces, if they're fifths, if I need 5 of them to make a whole, 9/5 gives me enough for one whole, and then I'm going to have 4/5 left over. 9 divided by 5 would be 1, remainder 4. So again, we're seeing this pattern. We're seeing this again. Okay. One final one, just to show you that sometimes things will look a little different. 12 divided by 3 is the same as, well, top divided by bottom, top divided by bottom, 12/3. And if I wrote this as an actual division problem, 12 divided by 3, I think all of you would be very quick to scream, "It's 4, it's 4, it's 4," and you would be right. All of these numbers are rational numbers. Fractions, ratios, are just a way of representing the relationship between two integers, usually a division relationship. Again, please don't get discouraged if some of this isn't making a ton of sense. This is one of the big new things that we throw at you in 5th grade, so this is just kind of an introduction. Like I said earlier, the big thing to remember, the big thing I want you to hang on to, your numerator, the top, that's your dividend. Your denominator, the bottom, that's your divisor. Top divided by the bottom. All right, we'll do some more practice and have some more discussion in class. For now, as always, just make sure you have this copied, and I will see you then.